Well, hello. Today we're going to start doing an overview of transport processes. So we're going to do an overview of transport processes. So what we're going to start doing is looking at how organics or other types of contaminants move in the environment. So the transport of solutes in groundwater. So when we're talking about solutes, so we're talking really about solutes. What is a solute? A solute is anything that is dissolved in water. So when we're talking about solutes, we're talking about dissolved parts of it. So when we talk about, we'll get into the organics and we'll get into like how much they dissolve into water. We kind of got into a little bit of that. It has to be dissolved in water for it to transport in water. Okay, so that's part of our joys of doing groundwater work. There are different mechanisms that control this. So one is diffusion. So diffusion. Diffusion is the spreading of a solute in response to a concentration gradient. So a concentration gradient is formed, and so it's a spreading of it. Spreading. So this is my shorthand for what do you call it? Concentration. It's a spreading of the solute due to a concentration gradient. So this is really important for some systems. So when we're talking about things diffuse, especially when we're talking about contaminants that get stuck into or like absorb or absorb onto pure phase, like we talked about in apples, gets absorbed onto things and then they diffuse off slowly, and so we can get this constant diffusion going on. So this is very important for that. They also move by advection. So advection is transport by flowing groundwater predicted by Darcy's law. So this is the predicted by Darcy's law. Darcy's law, this is the transport of flowing groundwater. So transport of flowing groundwater. Okay, so advection, a lot of times when we think about advection, it moves as a pulse. It moves as a piston flow. And we'll get more into that, but that's really piston flow is advection. The third mechanism here is mechanical dispersion. Mechanical dispersion. This is the spreading of a solute due to variations in flow velocities. So this is spreading due to flow velocity changes. So these could be really variations. So this is variations in flow, variations in velocity changes. So these could be micro or macro scale. So we turned out a pump, now all of a sudden the velocities change. So we're seeing changes in velocity. Again, that's my shorthand for velocity. So these could be on micro scales. So when we look at transport, especially around around things, you can get faster or slower flow, even in groundwater, like little variations in the flow, if you do not have laminar flow. So Darcy's law assumes that you have laminar flow. So what is laminar flow? That's when flow is straight across. So if you've seen those things where, the car is driving and the smoke goes around the car and it's all perfectly smooth and everything, that's laminar flow. It's just moving like this. If you get to chaotic flow, and you can get this with variations in flow where you start getting things mixing, you can get some mechanical mixing of the solution there. We can do this when you got the slug. You see this more with surface water than you do with groundwater. Another big mechanism that can impact it is sorption. And we already talked about sorption. So that's the attachment of a solute to a mineral surface or the soil organic. So this is attachment. And this will result in what we call retardation. So retardation is where we're having the solute being actually retarded in its flow. So groundwater moves, we usually say the retardation factor for groundwater is 1, because there's no retardation to it. But then as a solute is retarded in its flow because of absorption, or we're also going to talk about transformation. The other one is transformation. And transformation and absorption cause retardation of the compound. So absorption is an attachment. to a mineral surface of soil, it's often reversible or partially reversible. So we talked about like dissolves like, so being absorbed onto the organic material. Also, like with hydrogen bonds, covalent, hydrogen bonds, because clay has, at normal pHs, clay has a negative charge, and so things will get sorbed onto it. We'll get really into detail. If you ever take like a soil physics class, you get really into detail with that. And then, so this will flow relative to groundwater. So a lot of times, a lot of the organics that we've been talking to go through sorption. And then the last one is transformation. This is the process that changes the compound. And usually this is often irreversible. So this is reversible. Oftentimes this is reversible. I mean, we can, like a lot of things in science, there's always that one thing that messes it up. And then transformation is often irreversible. So once it's been transformed, it usually does not transform back. Examples of transformation would be something like radioactivity. So when you go through the half-life of a compound, you go through that half-life, well, that half-life will decrease the original compound. So it'll go through there. We talked about biodegradation. That is a transformation process. You can also get chemical reactions. So you can get things that react to sunlight or different chemicals. Things will precipitate out onto a mineral. So you can get, if you've got, say, calcium or magnesium in the water, it can precipitate out of the system and form, coatings on things, so it can come out of solution. So transformation. So what we're going to do now in this class is we're going to go through each one of these different things in order. I think I have it set up so we do them in this order. We'll try to get through diffusion and advection, and then I'll give you a homework assignment once we get through advection, and then we'll stop at advection hopefully for today or sometime there. Okay, so this is the overview of all the processes that we're going to be talking about, and then we will be adding things to the advection dispersion equation. So the advection dispersion equation, look this up, and then we're going to be adding to it because we're basically going to be talking about advection and dispersion. We're going to add in diffusion, and then we're going to add in retardation into it in order to be able to see how contaminants move. So generally when things move by effective flow, if this is time and this is concentration, things when they move by advection move like this. So all of a sudden it'll come and it'll arrive at the well. So that's what we're going to talk about. Okay.